Hello everyone, welcome back to another MCR3U1 video, and we are continuing chapter 2, and today's topic can be found in section 2.6 of the textbook, and it regards multiplying and dividing rational expressions. And again, this video will be the theory part of the section, and we will do some examples in another video. Here's the chapter outline, and extra practice questions on section 2.6 can be found on pages 121 to 123. In the textbook. Okay, so let's get started. So this is the success criteria for this lesson. We want to use the principles of dividing and multiplying rational numbers with no variables, just as we usually do, like a number over a number times another number over another number, right? With no variables at all. We want to use these principles to be able to multiply and divide rational expressions and also determine restrictions for the final expression after we multiply, after we divide. Let's start off by looking at the general blueprint when we multiply or divide rational numbers, because we want to use the same blueprint to multiply and divide rational expressions. So when we multiply two rational numbers together, we want to multiply the numerators together, right? And then we want to multiply the denominators together. And we get a single expression with multiplied numerators at the top and multiplied denominators at the bottom. And this is the same when we multiply any rational numbers, and we're going to use this to multiply rational expressions. When we divide rational numbers, we want to multiply the first number by the reciprocal of the second number. So this is the number, this is the reciprocal of the number, right? And you see how we're going from division to multiplication, right? So we basically just kind of want to flip the second rational, right? We want to flip this rational and then switch the division sign to a multiplication sign, right? Dividing by CD in this case, dividing by D over C in this case would be the same as multiplying by C over D, right? If we flip the second expression, right, is the dividing by this expression is the same as multiplying by the reciprocal of it, right? That's why we flip it. So we can see that we're going to use very similar processes to solve multiplication or division questions, right? Because in division, all we do is flip the second rational, and then we just multiply it, and we use the same blueprint as we used in multiplication. So we just want to multiply the numerators, multiply the denominators, and we get the multiplied numerators over the multiplied denominators. Let's go over the steps we need to take to multiply rational expressions. So, step 1, we want to factor the numerators and denominators of both rationals if possible, just as we did with addition and subtraction. This will again make it easy to see restrictions or divide out any common factors that we see. And throughout the whole evaluation process, we want to take note of any restrictions like we do here, because we could sometimes be working with very long rational expressions, and if we don't know restrictions along the way, it could risk us canceling out factors and then not noting those restrictions down. So for example, if we have a large expression here and an x minus 2 on top over a bunch of factors and x minus 2, and we cancel these out, and at the end of the question, we have our final solution over here, right? Since we cancel these out, we don't see them down here. And if we don't see them by the end of the questions, if we're working with very large rational expressions, we could forget about these, right? And to prevent that, we just want to note it down along the way that right here, x cannot be equal to 2, right? Because if it is equal to 2, the denominator will be 0, and it will give us an undefined expression. Okay? So, step 2, we want to use... let me actually explain the example that we have here. We have x squared minus 4 all over x plus 6 squared times x squared plus 9x plus 18 all over 2 times 2 minus x. And so what we're doing on the first step is just factoring this, then factoring this, then factoring this, and then factoring this. So we just want to factor all the numerators and all the denominators. Here we have a difference of squares, so we just want to put it in the form of square root of the first number, or of the first term, which is x squared. Square root of that is x. Square root of the second, which is 4. Square root of 4 is 2. And then we do x minus 2 times x plus 2 like we've done before, all over x plus 6 squared, because that's already factored, times the other numerator up here. It's a simple trinomial, and the two numbers that add to 9 and multiply to 18 are 6 and 3. So we just want to put it in the form of x plus 6 times x plus 3 all over 2 times 2 minus x, which is already factored, right? So we have factored everything, and here we want to take note of the two restrictions that we see. We see that here x cannot be equal to 2, right? Because we will get 0 in the denominator if that's the case. And here x cannot be equal to negative 6 because we'll get 0 in this denominator. Okay, so moving on to step 2, we want to use the multiplication blueprint that we learned in the last slide for rational numbers, and we want to multiply the denominators and numerators of both rationals. So once we do this, we'll end up with one large rational expression like we see here. So here, once we have factored, we bring this all the way down here, and we just want to multiply the two numerators and multiply the two denominators and make them one big expression. And take note of this because it's important for the later steps. Over here, we have a 2 minus x, which turns into a negative 2 plus x. And you might say, oh, how does that happen? We actually just factored out a negative from this factor, right? So here the x was negative, here the 2 is positive, and here the signs just flip. X is positive now, 2 is negative, and that will make it easier for us to cancel out common factors later on. Okay, so just take note of that. Step 3, we want to cancel out any common factors that appear both in the numerator and denominator. So in this case, again, remember I told you we factored out a negative sign. It was to divide out with this factor up here, right? Here we have a positive x and a negative 2. Here we have now a positive x and a negative 2. If we didn't cancel out that negative sign, right, we'd have a positive 2 here and a negative x here, and so it wouldn't be the same as this factor, so we wouldn't be able to cancel them out. But because we factored out that negative sign, now we can, and it's all good. And we have two factors of x plus 6 on the bottom, because we have an x1 and 2 here, and we have an x plus 6 on the top, so we just want to factor this one out, and one of these two out, right? So that's why I just crossed out the exponent, because now we just have one x plus 6 on the bottom, and that's it. And then here is the simplified form, taking out all the common factors, right? And this other final expression, or whatever you want to call it, is just I just put the negative sign on top just so you can see that you can, or you could put it here. It doesn't really matter. You can play around with the negative sign. And now step 4, we realistically do it throughout the whole question, but at the end we just simply want to note down all the restrictions for our variables. So these two are the ones we found out in the last page. I'll go back for a second so you can see right here. And at the end of the questions, we just really want to note them down, because we could have more throughout the question, and we could just, put a final statement at the end, noting them all down. Now on to dividing rational expressions, and this process will almost be identical. We are just adding one more step in between. Again, we want to factor the numerators and denominators if possible. So in this example, we have a 21y minus 3y squared, which we factor out a 3y, and we get 3y times 7 minus y. We have 16y plus 4y squared, and here we can factor out a 4y, and we get 4y times 4 plus y. We have a simple trinomial here, which we factor to y minus 7 times y minus 2, and another simple trinomial here, which we factor to y plus 3 and y plus 4, right? Just factoring everything. And here, again, we want to note down all the restrictions that we see. So here, if y is equal to negative 3, right, it'll make the denominator equal to 0. So we just want to note that down, that y cannot be equal to negative 3. And here, if y equals negative 4, then it'll make this factor 0, and multiply by this factor, the denominator will be 0, and that will be undefined. So we just want to take note that y cannot be equal to negative 4. And here, if y is equal to 0, it'll make this whole denominator 0, so y cannot be 0. And here it's just negative 4 again, which we already have here, right? So y cannot be equal to negative 4, negative 3, or 0, right? So let's continue. Step 2 will be our new added step for the division process. We want to use the division blueprint we saw in the last in a couple slides back, and we want to multiply the first expression by the reciprocal of the divisor or the second expression, right? So here we have the second expression, and once we flip it, or once we take the reciprocal, we get that. And we simply just want to flip it again and multiply the two rationals, right? So here we have y minus 7 times y minus 2 on the numerator, and here we have it on the denominator. Here we have y plus 3 times y plus 4 on the denominator, and here we have it on the numerator, right? And then once we take the reciprocal, we change this division sign to a multiplication sign, and we continue. And here, since we flipped the second expression, now the denominator has changed. So now we have even more restrictions to note, right? So here, if y would be equal to 7, this denominator would be 0. So y, therefore, cannot be equal to 7. And here, if y was 2, it would make this denominator 0. So y cannot be equal to 2 as well. And here we note all those restrictions down. And you might be thinking, oh, but since this is the final denominator, why do we need to note these restrictions up here? Well, throughout the question, we have this as a denominator, right? We can't just ignore that. Because if, for example, we were just using this expression right here, and you were, I don't know, plugging in values and evaluating the final values for, or final one final numerical number, if you plugged in y equals -3, you'd get an undefined rational number, right? So we can't have that. So these are also restrictions, as well as these. We have to find every single denominator in the question evaluation and take note of those restrictions, all of them. Next, step 3, we want to again use the multiplication blueprint and multiply the numerators and denominators, right? So here we multiply these numerators and these two denominators, and we get this long final single rational expression. And again, take note of this 7 minus y. We have factored out a negative from this 7 minus y over here, right? And the signs are just going to switch. So the y is negative here. Now the y is going to be positive. The 7 is positive here. The 7 is going to be negative here. And we do that for the next step so we can cancel out some terms. And you will see how we do that. So moving on to step 4, we want to divide out all the common factors that appear in the numerator and the denominator. And here you go. Here you see why we took out that negative sign, because now we can factor this term or this factor with this factor on the denominator. And if we didn't factor out that negative sign, this 7 would be positive, this y would be negative, and on the bottom, this y would be positive, this 7 would be, sorry, this y would be positive, this 7 would be negative, and they wouldn't be the same factor. But since we factored out that -1, now we can cancel them out because they're exactly the same. We also want to factor out this 4 plus y and y plus 4. They're both positive, the 4 and the y, so they're exactly the same. We can cancel those out. And we have a y right here, which we can also cancel out, right? So then that equals this expression. And again, you can switch around the negative sign to wherever you want. You can put it here, you can put it down here, wherever you want. And that is our final answer. And finally, for step 5, we want to note all the restrictions we have found throughout the evaluation process. And remember, we found restrictions on 2 of the steps, and right here, we just, you want to note them all down in one final box or whatever, right? So we can see that the multiplication and division processes for rational expressions are very, very similar. But we can also see that both processes end in multiplication. Because even when we divide rational expressions, we can just multiply by the reciprocal, right? So if we have, like we said before, a over b divided by c over d, right? We just flip this second expression, and we make this division sign a multiplication sign. And we multiply by the reciprocal, and then we just use our multiplication blueprint to get our final answer, right? So we always end in multiplication. And that's pretty much it for the video, guys. Thank you for watching, and in the next video, we will take a look at some examples using these 2 theories.